Hi ladies, in this video we're going to go through a bit of theory for 8E, which is two-step experiments using tables, and we'll also do some questions from 8E. And remember there's a second video which will go through the challenging questions. Okay, so two-step experiments basically mean that we do one thing and then we do it again, basically. So if we were to maybe toss a coin twice, or roll a die twice, or maybe pick two people to be on a team or something like that. Okay, you have with replacement and without replacement. So one just means if we have replacement means that you can select the same thing again. Without replacement means you cannot select the same thing again. So what we've got here, the two examples, we've got with replacement and the first selection and then the second selection, and then without replacement, first selection and second selection. So if we just look at the selecting three digits, 1, 2, 3, or if you want to pretend they're people, you can call them Harry, Mary and Sally. So basically on the first selection, we can pick either the number 1, 2, or 3, and that's represented in our outcome space or our sample space as the first number. Okay, so you can see 1, 1, 1, 2, 2, 2, 3, 3, 3. And I just realized that you can never see my pointer on these things, so I might just do that again. So the number 1 is represented here, number 2 represented here, number 3 represented here. So it's the first number in those pairs of numbers. Now, in the second selection, you can see it refers to the rows. So here we've got the 1, the 1, the 1, the 2, 2, 2, 3, 3, 3. So you're basically just reading it columns and then rows. Now, that is with replacement. So we can select the number 1 twice, we can select the number 2 twice, and the number 3 twice. But if we had without replacement, so let's say the number 1 was already chosen, we can't have the number 1, 2. Sorry, not 1, 2, 1, 1. Sorry, I was looking at this number 2 when I said it. We can't have 1, 1 because we've already selected the number 1. Okay, we can't have 2, 2 because we've already selected the number 2. And we can't have 3, 3 because we've already selected the number 3. Okay, so think of it as if we've got the numbers 1, 2, 3, you need to select the first time. I'm going to highlight in yellow. I select the number 2. That means I can only then select from the number 1 or 3, okay, because 2's already taken, and then I might select the number 1. Okay, so that's represented by the 2, 1. Okay, so it's probably a bit easier to understand when we've got an actual context to refer to. So let's have a look at these questions here. And I haven't set up. Sorry, just bear with me. I usually do this before the video. Okay, just give me a bit of space to work. All right, question 3. So here we've got the word set, so a 3-letter word. Show the sample space using a table. And we've got, should have read this properly, without replacement. Okay, so once we've taken a letter, S, E, or T, we cannot use it again. So the first selection, you can have S, E, T, and the second selection, S, E, T. Now, the easiest way to do this is because it's without replacement, we cannot select a letter twice. Okay, so we're not replacing it. So once we've selected the letter S, we can't select it again. So the option SS is not available. The same with E. If you selected it once, you can't select it again. And T, you can't have it twice. So you can't have SS, you can't have EE, which is represented here, or TT. So that means, excuse me, we can only have S, E, or ST. We can have E, S, or ET, and we can have TS and TE. Okay, so I'm just reading the column first and then the row. Now, just to reiterate what I was saying before, if I've already selected the S, I can't select it again because it is without replacement, which means I'm not putting the letter back. Without. Okay, question B, find the probability of obtaining the outcome ET. So we want the probability of ET. And we can see it, where is it? Here. So it's only once. And how many possible outcomes do we have? We've got 1, 2, 3, 4, 5, 6. We don't include the ones that we've crossed out. Okay, so just the outcomes that are there. All right, selecting 1T, the probability of 1T. So we count how many options have, or how many outcomes have a T. So we've got 1, 2, 3, 4. So 4 over 6, and we should always simplify our fractions, so that's the same as 2/3. Selecting at least 1T, that's going to be the same thing. So at least 1T. So we could have TT, but because it's without replacement, we can only have 1T, so it's going to be the same, 2/3. Selecting an S and a T. Oops, S and T, sorry. So we've got ST and we've got TS. So there's 2 options out of 6. So the probability of that is 1/3. And selecting an S or a T. Probability of S or T. So we've got 1, 2, 3, 4, 5, 6. So the probability is 1. All right, let's move on to question 5. Just make sure we've got enough space for ourselves. Okay. Question 5. In a quiz, Min guesses that the probability of rolling a sum of 10 or more from a fair 6-sided dice is 10%. From 2 fair 6-sided dice is 10%. Complete the following to decide whether or not this guess is correct. Okay, so she guesses that the probability of rolling a sum of 10 or more from 2 6-sided dice, okay, is 10%. Complete the following to decide whether or not this guess is correct. Copy and complete the table representing all the outcomes for possible totals that can be obtained. Okay, so this is just filling in this table here. So we've got, and we're adding them. So you can see 1 + 1 is 2, 1 + 2 is 3, 1 + 3 is 4, 5, 6, 7, and then we do the same here. So 1 + 2 is 3, 2 + 2 is 4, 3 + 2 is 5, 6, 7, 8, and then 1 + 3 is 4, 2 + 3 is 5, so you can 8, 9, 4 + 1 is 5, 4 + 2 is 6, 6, 7, 8, 9, 10. Okay, and you can see the pattern happening. Okay, so what we want is 10 or more. So I'm going to circle all the numbers that are greater than 10. 1, 2, 3, 4, 5, 6. So we've got 6 in total out of a sample space of 36 numbers. So 6 over 36 is the same as 1/6, which is, I know, is not 10%. Let me just quickly get on my calculator. Okay, so 0.167. So it's 0.16666 recurring. And if we're doing that as a percentage, it's approximately 17%. Now, she says it's 10%. Oh, we don't have to do anything. State the total. Oh, okay. I feel like I've answered the question. So we've copied and completed the table. State the number of outcomes. So there's 36. Find the number of outcomes that represent. Okay, I'm just reading ahead because I'm wondering why I answered that question and where that question actually is. All right, let's go back and we'll just answer the questions. Find the number of the outcomes that represent the sum of 3. So this time we're just doing number of outcomes. We're not finding a probability. So I might do this in a separate color so we don't get confused. So we want a sum of 3. So we've got a 3 and a 3. So there's 2 numbers have a sum of 3. Sum of 7. We've got, you can see on the diagonal. So there's 6. Less than 7. So everything on this side of the 7. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Less than 7 is 15. So we're not including 7. We're, sorry, I'm having a bit of a blank. Less than 7, so it's not including 7. Find the probability that the following sums are obtained. So 7 we found was 6, so it's going to be 6 over 36. So the probability of that is 1 over 6. Less than 5, so we've got 1, 2, 3, 4, 5, 6. Oh, it's the same thing. 6 over 36, which is 1/6. Greater than 2. Now, this is easier to do 1 minus what you don't want. So we'll do 1 minus just the 2. So 1 minus 1 over 36, which gives us 35 over 36. At least 11. So we want 11 or more. So it's going to be 3 over 36. Oh, it's not very good. That's 1/12. Sorry, I feel like I'm writing all over the page here. Find the probability that the sum is at least 10. At least 10. So let's do 1 minus. Oh, no, sorry. At least 10 means 10 or more. So that's what I did do before. So we've got, this is your answer here. So 17%. So Min's answer, or Min's guess is not correct, but she wasn't too far off, I guess.